The in-memory provider came to us with the first iteration of EF Core. We had never had anything like it in Entity Framework. The provider emulates relational database basic behavior using lists in memory. It can't stand in for some intricate, unique relational database behaviors, but it does cover a lot of general scenarios. If you're not new to testing, what this replaces in so many scenarios is using mocks, a technique that's been around for a long time to avoid having to use external services like a database in tests. The tests we're about to build will still be an integration test. Even though we're cutting out the database, we're still integrating with EF Core's APIs. I've done some preparation to the solution already. I first needed to add the Microsoft Entity Framework Core in-memory package to the test project. The other change I made to the solution was that I copied the database tests class to a new class in a new file called in-memory tests. Let's see what it takes to transform this test to use the in-memory provider instead of the database provider. I need to modify the DB Context Options Builder to use the in-memory provider instead of SQL Server. You do need to pass in a string to give a name to that instance. And this is interesting because it's how EF Core keeps track of different instances of the provider in memory. Sometimes you want a unique instance for each test, but there are times you may want to share an instance and whatever it has in its memory across a few tests. I tend to use a name that relates to the test name, so I'm just copying the name of the method CAN-INSERT-AUTHOR into database as the name for this instance of the in-memory database. In Michael Perry's EF Core 6 Best Practices course, rather than using the name of the test as the name of the database, he just creates GUIDs, which ensures that the names are unique. That's a pretty cool alternative. Now, when I instantiate the pub context with existing code, the new version of the Options Builder options will get passed in. There's no need to use ensure deleted or ensure created methods with the in-memory provider unless you're doing something that's a little more advanced. So I'll just delete those two lines of code, but I'll leave the right lines in here because I want you to see how the in-memory provider handles keys. Let's run this test, and it passes. Now let's look at the output. Well, this is interesting. The ID was already set to 1 before I saved it. Adding the author to the DB set caused EF Core to change its author ID to 1 right away, which is very different than what happens if you're waiting for a database to generate that ID for you. Because the in-memory provider is just lists in memory, even though it does know how to increment IDs, it's doing it as the entity is being introduced into the change tracker. Save changes doesn't really impact the ID beyond what calling add has done. So I'll remove that along with the two write lines to output the IDs. This assertion really only makes sense when we're testing with a real database. If you want to just be sure that the context does know what to do when you've asked it to add, you could either just check the count of the authors that the in-memory provider is aware of, and because it's a new instance, that would always be 1, or you can check that the state of the entity is added. That's what I'll choose to do, and here's how I would code the latter. I'll test the equality with R equal instead of R not equal, and I expect my result to be entity state added, and what I want to check is the state of the author entry as it's known by the context. So I'll run this again, and it passes, and that solves the problem for me. And it's much faster because I'm not asking the change tracker to do as much work. So that's a quick look at the in-memory provider on its own and using it to test something about our pub context directly. Now let's see how to test your application logic that uses Entity Framework rather than writing tests directly against the DB context. Our publishing company has been growing by buying smaller publishing houses, so every once in a while they have a need to import a bunch of new authors all at once. It's time to create a reusable method to import these authors. So far with the console app, anytime I needed new logic, I just shoved it into the program file. And what I want for importing the authors is a method that's accessible to various parts of the application. So rather than adding it to the program file, I'll put it into its own class. Not only is this more realistic for building an application, but keeping it in its own class will also allow me to test the new method more easily. I've added 2 new classes to the console project. One is called Import Author DTO, and the other is Data Logic. Import Author DTO is a DTO, it's not an entity, and it's specifically to help us pull authors into our application. It has a first name and last name, and to make it easy to use, I've created a constructor that takes those in. Like the controller we worked with in the ASP.NET Core module, the DataLogic class has a constructor that takes in an instance of pub context and then sets it to a local _context variable that it will use for data access in this class's methods. And to keep my console app working without a lot of extra effort, I've also added a parameter list constructor inside this new class. And I have added my new import authors method. This method lets me import any number of authors by passing in a list of my new author DTO class. Then the method iterates through the DTOs, creates a new author from each one, and then adds it to the authors DB set. When it's all done, it calls save changes. But instead of just calling save changes, I'm going to capture the result of save changes, which is the number of rows affected. And that result is the return value of the import authors method. So now I just want to make sure that this new import authors method is working. And rather than running and debugging the console app in order to do that, I can write a test that verifies the method. And here's where this type of test will differ from the in-memory tests we already built. The first test was testing the pub context and its behaviors. But the focus of this test is to test my DataLogic class, which happens to use a pub context. So I still need to use the in-memory provider and verify that the import authors method returns the correct number of new authors. As with the first test, I start by creating a DB context options builder and configuring it to use the in-memory database provider. Then I set the name of this instance to insert authors returns correct result number, the name of my test. Next, I'm setting up the test data, a new list of author DTOs that has 3 items in it. The values here are inconsequential, so I'm just calling them A, B, C, D, etc. Now, another difference from the previous test, instead of instantiating a new pub context, I'm going to create a new instance of DataLogic using the overload that takes a pub context. And I'll create that context as the parameter of the DataLogic object. And don't forget, I need to pass in the builder options to this new pub context. All of this injection makes for some really easy to read, but also very succinct code. The last bit of setting up this test is to finally call the DataLogic import authors method, passing in my author list, and then finally, here is the assertion. And the assertion tests that whatever the count of my list is matches the value of the result. In other words, the number of rows affected when my import authors method calls save changes. Before I run my tests, I'm going to do something that may seem a little weird. I'm going to change the assertion to suggest that the result should equal 5. This is a common practice for testing, and you'll see the benefit when I run the test. Notice that the test failed, and we knew it would because I've only got 3 items. But the output explicitly says this assertion expected 5, but it only got the value 3. So I'm actually seeing that not only is insert authors working, but my test is written correctly as well. I know that the correct value came back. Now I'll go back and change the assertion to what it really should be testing, which is the count of the result. And I can do that with the confidence that when I run this test and it passes this time, that I know it's passing for the right reason. And I have double the confidence that my insert authors method is working. Because I separated the EF core calls into their own class, how does that affect my program class? That no longer needs to be aware of Entity Framework or of the pub context. It only needs to be able to instantiate a DataLogic object. I've created a new method and program called Add Some Authors, which creates a new list of 5 import author DTOs, instantiates that data logic, and calls import authors, passing in the dictionary. Because I'm not providing a pre-configured pub context, this will use the default configuration that we've been using all along. I'll go ahead and run this, and we'll be stopping at a few breakpoints that I've put in. Here's the data logic parameterless constructor getting hit. There's one in pub context where the database gets configured, so you can see that running the console app will trigger our original configuration. And I put another breakpoint when Save Changes is about to be called, so we can look at debug view to see that it is indeed about to send all of those new authors into the database. And when all's said and done, there are the new rows in the pub database. So we can have our cake and eat it too. With this new architecture, where we've started applying separation of concerns, we can use tests that will use the in-memory database and run the application that will use our development database. And overall, our code is more readable, more maintainable, and more testable.